A group of 16 people will be partitioned into 4 indistinguishable 4-person committees. Each committee will have 1 chairperson and 1 secretary. The number of different ways to make these assignments can be written as 3 to the r times m, where r and m are positive integers and m is not divisible by 3. What is r? So first we're going to find the total number of committees we can make, and this turns out to be a pretty standard overcounting problem. So to find the number of committees, we can first choose the first committee of 4 people in 16 choose 4 ways. Once we've chosen the first committee, then there are 12 people remaining, and we need to choose 4 from those. This gives 12 choose 4 ways. Similarly, once we've chosen the first 2 committees, there will be 8 people left. We get 8 choose 4 ways for the third committee. Lastly, 4 choose 4 ways for the fourth. Now the problem here is that the committees are indistinguishable, meaning that the ordering of the actual committees is not important. And so if we did 16 choose 4 times 12 choose 4 times 8 choose 4 times 4 choose 4, we're going to end up overcounting every possible set of committees by a factor of 4 factorial. So I need to divide by 4 factorial to get the true number of 4-person committees. So this expression gives the total number of committees that I can form. It's worth noting that we can actually simplify the numerator. The numerator is equal to 16 factorial over 4 factorial to the 4th, and I'm dividing that by 4 factorial. So this gives a simpler expression to work with, which is 16 factorial over 4 factorial to the 5th. This is the number of ways that 16 people can form 4 indistinguishable committees of 4 people each. Now we also need to take into account that each committee is going to choose 1 chairperson and 1 secretary. So here all we need to do is, for each 4-person committee, we need to choose 1 chairperson and 1 secretary. And the number of ways to do that is going to be 4 times 3 for each committee. So we need to take the number of ways to form the committees and then multiply our answer by 12 to the 4th. Because every committee there are 12 ways to choose a chairperson and a secretary, and there are 4 committees. So therefore, this expression that I've boxed here is going to give the number of different ways to make these assignments. Now, the nice thing here is that we don't need to fully compute this because we only need to find r. And r is the greatest power of 3 that divides this number. So first I'm going to look at 12 to the 4th. This clearly is divisible by 3 to the 4th, but not 3 to the 5th. Now I'm going to look at 16 factorial over 4 factorial to the 5th. So we can either use Legendre's formula, or we can just count the number of 3's in 16 factorial. We see that there are 6 factors of 3 in 16 factorial. And 4 factorial, there's only 1 factor of 3, but remember I'm raising it to the 5th power. So altogether, there's going to be just 1 factor of 3 in the expression 16 factorial over 4 factorial to the 5th. This means that the number of ways is going to equal 3 to the 5th times some number which is not divisible by 3. So therefore we can conclude that r is going to equal 5.